This is freestanding, compact, open circuit, suction type, subsonic wind tunnel used for studying the various aerodynamic phenomena for undergraduate and research projects. The models provided in these apparatus can be used to investigate the boundary layer analysis, drag and lift forces, pressure distribution around the bodies, flowing around the bodies submerged in the flying fluid, and also to flow visualization around the various bodies. As you can see, this wind tunnel consists of the air. This wind tunnel is taken from an effuser. The air from that effuser enters into a nozzle, also known as the contraction cone, which is used to accelerate the velocity in a linear proportion, and then after that, from this the accelerated air passes into this test section, or we can say transparent test section, and the working section. From the working section, the accelerated velocity, accelerated air passes through this diffuser cone, then through variable speed axial fan, and finally into the atmosphere. The apparatus consists of an axial fan whose speeds, the motor whose speeds can be varied to vary the velocity inside the test section. The speed of this axial fan can be varied with the help of the screen provided here in the control panel. This control panel consists all the instrumentation and the digital displays used for the various parameters such as the velocity, differential pressure, and the differential pressure, your drag force, lift force, displacement, and the angle. As you can see, this is a touch screen HMI 7-inch in the size. Given a button to switch on and off the motor, with the help of this slider, you can vary the speed of the motor and thus the speed of the air in the test section. Tare buttons are given to offset the values on the displays to the 0. As you can see, this also consists of a 32 dp display unit. The pressure distribution flowing around the body can be measured with the help of this 32 dp display unit. The display of this 32 dp can be obtained with the help of this screen also. By pressing this, you can go to the next screen, and you can see here the digital display of 32 differential pressures. With the help of this, you can go to your main screen. Apart from that, it also consists of a manometer, which is a very conventional way to find out with the help of pitot tube and analog instrument to find out the velocity and also the pressure distribution around the body. This manometer can be tilted to different angles It helps to scale up the readings in case the velocity flow is very less, or the difference between the 2 points is very less. In that way, you have to tilt this manometer to scale up your readings. You can tilt this scale up to 60 degrees. With the help of this bottom holder, you can make it move up and down, and depending on the head of this water level, your manometer level will also get affected. So you can control the water level as per your requirement. For that, you have to switch on this ball valve, and you can see. If we talk about the test section, our test section is 300 into width, 300 into height, and 600 in length. It consists of, at the top of the test section, we have 3 points which can be act as a static point as well as the points for the pitot tube to be inserted through these points. This is the pitot tube having 2 pitot. This is pitot-static tube, have a dynamic total and the static points to measure the velocity. It also consists of an LVDT. This LVDT helps to determine the displacement of the pitot up and down vertically. various accessories can be inserted with the help of easy points knobs given to the head. As you can see, if I remove these knobs, this will come out and then very easily take out the accessory. Each accessory comes with this type of attachments. You have to put this again. We have to match these two holes and then fix it with the help of knobs given. You can tilt, and with the help of this angle scale you can know the angle at which you have tilted your motor. Now connecting model is a pressure distribution around the front board. Apart from that, another accessory which can be easily fitted in a similar manner as we shown earlier with the help of the two knobs, and this is a displacement unit with angular feedback unit with 3-axis load cell. Means you can find out the drag force, lift force and the pitching. This can be easily fitted like this, and you can fit your model under study here. You have to lose this null nut, fix in this, and then tighten the and then you can fix this in the front meter like this. So there are connectors given that is to be connected on the side of the control panel. The first one will show you the differential pressure, connector for the differential pressure. Second will show you the velocity, that is calibrated directly in the velocity. On the side of the test section, here are two differential pressure transmitters are installed with the connectors. One will show you the readings in pascals differential pressure, and another is calibrated to show you the velocity in meter per second. Suppose you want to know the velocity inside the test section, you have to make it adjust with the help of this around the test section, and then connect the two pipes for the total static head and the total. At the side of the test section, you will see the two pressure transmitters. One pressure transmitter is calibrated to give you the reading in terms of differential pressure in pascals, and another transmitter is calibrated to give you the reading in meter per second to determine the velocity inside the test section. For that, there are two connector points are given that is to be connected with this pitot-static tube having 2 points, one for total pressure and another one for static pressure. You have to take care that which point is to be connected to which one. The higher point will be connected to one side and the lower point to the another side. Then when the wind air from the suction side, the suction from the outside side, you will get the two difference pressure, and those difference pressure is calibrated to give you the velocity in meter per second. Similarly, if you connect these 2 points of pressure transmitter that is calibrated in the pascals to these 2 points, you will get the difference of the pressure between the total and the static. Similarly, the same points can also be connected to the 2 points here, there in the manometer. Then you will see the difference in water column on this manometer, and then you can calculate by formulating that with the formula, well-known formula of 2gh by rho, to calculate the velocity inside the test section. So in this way, we can also check out the calibration level. Means the velocity calculated with the help of this differential pressure, with the help of this calibrated meter per second, and with the help of manometer should match to each other. Now we will see how to operate this open circuit wind tunnel. before starting the run, you have to make sure that all connections are intact in their place. This is a 32-point connector that is connected to the point here, and this is the power supply that is connected to be here. Then both these connections are in place, only then these two will be communication with each other. Apart from that, you have all the connectors should be ready. Like this one connector is for the pressure transmitter that is calibrated in meter per second. This is the connector that is for the pressure transmitter that is calibrated in pascals. This one is the connector for the encoder, which gives you the angle. And these three are the connectors which gives you the readings of the load cell in drag force, in X direction, in Z direction and the Y direction. X direction denotes the drag force, Y direction denotes the lift force, and Z direction denotes the pitching. And this one is for the LVDT as indicated here. This one is for the angle, and this one. Now, how to start the panel? This is the on-off switch. You have to switch on this rotary switch and wait for the screen to come. When the screen comes, you will see all these display units here. So if you want to tear the displacement value, you have to press it on to make it 0. Similarly, you can make that angle also 0. Drag, lift and Newton force, you can make all these forces also 0. This is the button to go to the next screen, that is 32 display unit, DP unit. Here you will see all the points are 0. Then you have to press onto the motor, give some speed, and you will see see here the velocity in the test section is 17.5 meter per second. If you want what is the differential pressure, again you have to connect those with this one. Again, if I want the readings in differential pressure, then I have to connect the points on the pitot-static tube to the differential pressure manometer.